I'd like to talk a little bit about the accuracy of what we do here in Civil 3D. And I want to show you how important it is to be very, very accurate, very precise. This right angle here might represent a corner of a property. It might represent the returns on two streets or something like that. The first one, I'm going to use the fillet command, and I'm going to put a 30-foot radius between these lines. Using the fillet command gives you exact uh, um, tangent lines and curves. These lines are tangent to the curves. The other way that I've seen people do it is they try to kind of fit an arc in here as best as possible, and they might do something like that. You might look at that and say, well, that's pretty good, although this one probably needs to come back here a little bit farther. And you go, that to the visual eye looks pretty darn good. But we're going to check the tangency of the lines and the arcs. We're going to find out that this is not good and what problems it's going to cause down the road. So one way to check tangency is to start a polyline command with pline and use and select with the object snaps the one end of the arc. I'm going to turn ortho off. I'm going to check the center of the arc, and then I want to be perpendicular to this line. And if these two lines are not exactly right on top of one another, then it's not tangent, and it'll cause problems down the road. We're going to check this other side. I'll select the end of the arc, the center of the arc, and then perpendicular to the line. And again, we see a problem here. If I check the filleted version using that command or that procedure, you will see that these two lines are going to be exactly perpendicular. No matter where you go on them, they're going to be right on top of one another. I'm going to do a regen here. There we go. So if I keep zooming in, by definition, these are perfect and they are tangent. The real problem occurs when we start using labels for some of this stuff. And I'm going to put some labels on both of these curves, or the lines and the curves, I should say, of this. I'm going to do it here also. And what we'll find out is the bearings are the same on the lines, but the lengths are different because I threw these curves in at different methods. And the problem occurs is that when you use a label like this with three parameters, the delta, internal angle, the length, and the radius, that is assuming that the two lines on either side are tangent to that. And part of the solution for this curve is really takes place in these two other bearings. And so if you subtract these two bearings, the angles of these two lines, it should equal the internal angle. But one thing we might see here, if we copy this curve down here, is if I take that curve and I rotate it to another location, those values stay exactly the same. And so we don't know, as a surveyor, we don't know if it's that way, if it's this way. We don't know which direction that is, and it causes problems. This one, we know the direction because it's assumed that this line is tangent to that arc. Therefore, we have to use one of these and then use these three parameters to identify exactly how that arc sits in there. Now, when I say a broken back arc, what I'm talking about is an arc that I'll make a copy of these two lines off to the side here. And a broken back arc, and I'm going to draw these very out. Here's an outwardly broken back arc, and this is going to be, and I'll make that even worse. Those two are broken back arcs. They're clearly not tangent at the location where the line hits the arc. This one looks good, but in fact, we see that it is not. Because if we take the difference between these two angles, we will not find that this angle equals that if we do the math. This one would. The angle of this line and the angle of that line is going to equal the difference here just by simple geometry. So if we're going to have a broken back curve, and sometimes we have to in property lines and things like that, then we have to have one more parameter defining this arc. One of those parameters is the chord. The other parameter might be the line leading into it or the line leading out of it. So let me do an undo there. So we're going to use the chord. We're going to add an additional parameter to this label, or choose a label that has that additional parameter in it. And it's going to be CPS curve RL delta and chord. And when we say OK here, now we can lay, as a surveyor, we can lay this curve out. The other curve, without that additional piece of information, there would be no way to lay that curve out. If I take that curve and I rotate it, you'll notice that the chord bearing, this chord bearing here, is 52.1906 here, and it's 88.44.19 here. This one we can fully lay out just with those values. This one we cannot lay out without, we can with the chord bearing or with another piece of information, but by itself with just the three we cannot. And so that's why it becomes so important to make sure that our lines and arcs and stuff are tangent to one another.